Ever wondered how electricity reaches your home from power stations? The journey is quite fascinating, and one of the key players in this process is a device known as a power transformer. A power transformer is an electrical instrument that transmits electrical energy from one circuit to another without changing the frequency. They work on the principle of electromagnetic induction and play a crucial role in transmitting electrical power between generators and distribution primary circuits. These transformers step up or step down the voltage in distribution networks. And since they have no moving parts, they are considered static devices, functioning based on an alternating current electrical system. Let's take a moment to appreciate Faraday's law of electromagnetic induction, which is the operating principle for all transformers, inductors, motors, generators, and solenoids. Faraday's law suggests that when a closed loop is brought near a fluctuating magnetic field, an electromotive force or EMF will be induced across it. This is the magic that happens inside a power transformer. Now you may wonder, how exactly does this transformer step the voltage up or down? The total voltage in a winding is equal to the voltage per turn of the coil multiplied by the number of turns. Since the voltage per turn of the primary and secondary windings are the same, the induced voltage in the secondary winding can be related to the input voltage on the primary winding. This relationship is expressed by the equation V equals Vp divided by Np times Ns, where V represents the total voltage in the winding, N represents the number of turns of a winding, and the subscripts P and S refer to the primary and secondary windings respectively. The ratio of the number of turns in the secondary winding to that of the primary winding is called the turns ratio. Delving deeper into the components of power transformers, we find the core and the primary and secondary windings. The core supports the windings and provides a low reluctance path for the magnetic flux. It is made by stacking and laminating thin steel sheets which are insulated from each other. The vertical sections of the core in which the windings are carried are referred to as the limbs, while the horizontal sections of the core that couple the limbs are referred to as the yokes. The windings are made up of copper or aluminum conductor coil with a specific number of turns. Copper is the preferred material since it offers high electrical conductivity and high ductility, reducing the amount of winding and making the material easier to wrap around the core. A transformer consists of at least two windings, the primary and the secondary windings. The primary winding is where the input voltage is applied, while the secondary winding is where the output voltage is received. In summary, power transformers are not only essential for transmitting electricity from power stations to our homes, but they also ensure that the voltage is at a safe and usable level. They operate based on Faraday's law of electromagnetic induction and consist of a core and primary and secondary windings. By stepping up or down the voltage in distribution networks, power transformers play a crucial role in our daily lives.